and commitment to research excellence. The CSE Society, under the esteemed leadership of Dr. Chandra ma'am, convener of DevTalk 2026, has consistently worked towards fostering technical excellence, innovation, and collaborative learning among students through various academic and technical initiatives. Enigma, the official web and coding club of VSSUT, focuses on hands-on learning in web development and programming and functions under the guidance of its faculty advisors, Dr. Alina Yash ma'am and Dr. Gyanranjan Shial sir. DevTalk 2026 marks the inaugural edition of this new technical initiative, envisioned as a platform to connect students with industry professionals and real-world technologies beyond the classroom. It is now my privilege to introduce our speaker for today. Viraj Chandra sir is a software engineer at Google, an ICPC regionalist and an alumnus of NIT Raipur. With a strong background in competitive programming and real-world software development, he has mentored thousands of students in mastering data structures, algorithms, and actively contributes to developer community. We are truly excited to have him conduct today's workshop. In tomorrow's session, we'll also be joined by Rudra Madhava Mishra sir, a cloud engineer at Amazon and an AWS hero, and also
and for the yesterday also, and I welcome you all once again and utilize this time, this 2 day very nicely, and definitely I will say, as a faculty advisor of your society and your UG coordinator, maintain discipline throughout these 2 days. Thank you all. Thank you sir for your presence here, and we hope this workshop will give us a very good output. Thank you.
thank you ma'am. Now I would like to call Mr. Viraj sir to take over the session. Please join me and give him a big round of applause.
वीडियो बंद कर देंगे। रुके
Guys are Marvel fans and then you also know binary search. Okay, good. So very good combination. Those of you who don't know Marvel, do you recognize this person? You recognize this person? Okay. You recognize what this person is doing? What is this exactly? Right? So this is binary search. At least the binary search that you know of, right? The start of binary search that we know. There's an array, we take an array and we split the array, right? We split the array, that's binary search. Okay? Of course the array is, for example, sorted and all. So you're able to then work on the array, then you do again a split like this, again a split like this, and then you try to find some answer. Right? So this is binary search. Everybody understands this? Yes or no? Hello.
Sound ऐसे
Hello. Am I clear? Okay. I think थोड़ी कम आवाज आ रही है मुझे कम आ रही है कॉलर माइक से कम आवाज थोड़ी कम आ रही है ठीक है तो हेलो थोड़ा सा फास्ट hello cool. So this is binary search, everybody knows this, right? Okay, and you must know this guy. Okay, if you know this guy then you have to know binary search. If you don't know this guy then I would say watch, I think, Age of Ultron. That's the movie. Okay, you can watch that movie, you will get this guy and then you can come back to binary search. Alright, so that's a nice 2-hour break. Okay, so I'll start off with a very basic idea on binary search. There are two things that we normally cover in binary search. One is called being monotonic. Okay, I like to call it boring. And then there is something called as predicate. What is monotonic? English meaning otherwise is like just this part, mono, doing the same thing, same trend, same nature. So monotonic is like coming from this part that there is something called as monotonic functions, right? So monotonic functions look like this. You make a function, you graph it up, and it's, let's say, completely decreasing. Or, for example, the whole function is completely increasing, like this, for example. So this is monotonic nature. That, okay, I plot a function, it's completely decreasing, it's completely increasing, it's strictly decreasing, strictly increasing, but it doesn't show a nature that looks like this, so increasing for some, then decreasing, or something like this. Doesn't have that nature. This is monotonic function. Okay? And then what do we know of predicate? So predicate is any such question which you can answer in true and false. So let's say I ask you, do you enjoy this session? You can say true, I enjoy it, or false, I don't enjoy the session. So anything that can be stated in true or false terms is predicate. Okay? So we have monotonic, we have predicate, so predicate is like true and false, and monotonic is the same thing. So what happens in binary search is that normal binary search people learn is the array part. I have an array and I'm going to break the array and then I'm going to find some target value. That's the basic binary search. Okay. But binary search expands a little bit, and binary search says that I can be applied anywhere. I can be applied anywhere as long as you're able to identify the question having a monotonic predicate nature. If this is visible, then I can apply binary search. For example, let's say the question is given that you have to find the closest square number, like find x such that x square is closest to 100, for example, or not 100, it's 105, for example. Find such an x, such that x square is closest to 105. Now this is not a question which has an array, right? इसमें कोई array नहीं. There's no numbers, there's no array. I cannot split anything. I don't think there is a low and high that I can decide. Okay. So now how how do I think binary search would be applied here? I'm going to ask the right questions. See, I'm going to say that, okay, x the square करना है, right? I have to square x, assuming let's say x is being told that it's greater than 0. 0 square is 0, so I don't want to consider 0. I'm not talking about negative numbers. So x can be 1, x can be 2, x can be 3, 4, 5, so on. Something till you go till infinity. Correct? Okay? Now, what is x square? If I write x square is like 1, 4, 9, 16, 25. I'm bad at this maths, but yeah, I'll try to read. Okay, so x square is clear, right? Now I have to ask the right question that, okay, I am being told that I have to go closest to 105, right? If I cross 105, then that is something I don't want. So, can I say that a number that looks like means 0. So how will this graph look like? Go something like this and then a sudden drop and then false. Does this make sense? Yes? So you have truths and it suddenly falls and then the graph continues. So now I have somewhat like a function which is never which is always decreasing. It's never increasing, right? It was constant for a time. It was all truths. Then it fell and now it's all false. So I know that I have a monotonic nature. So I had a predicate, I had a monotonic. So I can apply binary search. This is what binary search is. Does this make sense? Okay. Now, binary search has two categories, and because I'm assuming everybody understood everything till here, आप लोगों ने कुछ binary search के questions खुद से भी लगाए होंगे, right? Correct? Is by the way Hindi for some folks? Okay, cool. So you must have applied for like some 2, 3, 4, 5 binary search questions. Is there anybody here who hasn't solved any binary search problem? Okay, great. So then you have applied this thing, right? Where classically we say something like this. We say that, okay, I'll write something like a while low less than equal to high, right? And then I do something, I write a checker function that I say, okay, I check this, that, okay, is this possible? Like for example, the question here will be, is the square less than 105? If it is, then it's a true. If it's not, it's a false. On the basis of that, I can justify where do I want to go, what do I want to do. So I'll say that, okay, right now x starts with 1, let's put some very high value, let's say infinity, and then you try to do the Captain America thing, you try to come in between. And you say, I'm going to come in between, I'm going to ask my question for some random capital X. Did x square is less than equal to 105? Oh, is it? If it is, then I know all these things are something I don't personally want. Correct? If it is, or rather this, what do you think? This half or this half? Left half, right? So if I know that x square is less than equal to 105, or rather, let's put it this way. In this, trend of true, false, which true are you trying to find? Are you trying to find this true, right? This true. That just place where you know that I would get above this and I will reach a false. I need that last true. So if let's say this guy, this question told you a true, that means you must be standing somewhere in truths, right? You must be standing somewhere in truths. आप यहाँ कहीं होगे? If you are somewhere here and the falses are somewhere there after that. Correct? So if you got it true, that means you're somewhere here. So if you're somewhere here, then you'll say, okay, I need this guy. That's a true after this. So please note this answer for me. this is a x, this is a viable x, I'm happy with this x, but I can do better. So I'll be like, okay, I'm happy with this guy. So I'll note this answer. I'll say, okay, answer is x, but let's make sure that my low, that is this guy, moves to something like x plus 1 probably, right? Moves forward. And if this guy actually gave you a false, what will you do now? You will say, okay, I must be somewhere here. I must have been somewhere here where I have all the false. Now, if I'm somewhere here, then of course I'm not happy, right? I don't want this answer. I'm not happy, so I would want to move. I'm moving anyways, I will still move, but I'm not happy, so I will not note the answer. Because this was never the answer, right? This is a value that's greater than 105. So this is never the answer. I got a false. I will move, but where will I move? All of this segment is still false. Should I move there? No. I'll come back and say, let me ponder over the left side, because I think the left side will have an answer, probably. Okay? So this is where I would have said that, okay, let's do something like a high equals to x minus 1. Alright? Okay. So now this is the classical integer binary search. Okay? This is something people mostly figure out. They realize everything is good enough. But there's a problem that happens is when people ask decimal binary search. Have you heard of decimal binary search? Right? What if in this same question I say that x cannot be an integer? Now I don't think you can get an answer like 10, right? 10 square is 100, but then it's going to be something like 10.1, 10.2, 10.3, 4, 5, something square will closely reach 105 because now you're talking in integers. Okay, so this is going to be today's topic. I'm going to try to make you understand decimal binary search without what would seem very hard exactly, because most of the people don't realize decimal binary search is just this. Okay, so let's try to tackle that. Abhi tak any doubt? All clear?
So the question was find the x that is closest to 105.
Right.
So if the number will be 120,
Find the x such that x square is
closest to 105. But instead of 105, if we check for 120, then the closest number will be 121, which is greater than 120.
Right.
So the logic phase less than 100, less than 5.
No, so I said that closest to 120 for example, right? So as soon as you get 121 as an x is, let's say, checked as 11, right? So 121 is high?
But it is closest to 100.
Oh, okay, that, okay. I understand. Okay, so let's say that this question is closest to 105 from the left. Okay? Good? That works? Thank you for this. I think I was making my thing, but yeah, that's good. Great. Okay, I think everybody gets this now. Thank you for that. What is your name?
Sir, Amit first.
Amit. Ramit. Okay, thanks, Ramit. All right. Cool. So let's try to handle decimal binary search. Okay. So let's understand what is decimal binary search. First of all, now that it's clear that binary search is not always an array. कोई ऐसा array नहीं देते हैं, nobody says to half it. But rather there is some range of numbers. There is a range that we have. It is like something here, low, something like high. It might represent an array, it might represent numbers, something like that. And then we try to half that range. Like, okay, this is the range. I'll half it, then half it, then half it, then half it, and land it. So that range thing we call as a search space. Where am I searching on? What is the space that I want to search on? So right now when we talk about integer binary search, right? It's a number line, let's say this is 1. And let's say this is 100. So you say that, okay, I'm going to pick up integers 1 and 100. I'm going to keep dividing by 2. And then I'm going to make sure that I try to half the search space. But now what happens in decimal binary search is the same question, let's say for example. They'll say, oh, find some x value which could go to points. Which could be something like 10 point something. So that is again 100 and closest to 105 from the left hand side, for example. Alright. So now, assuming let's say they say something like this. They say that, okay, please find your answer up till, now again, it's a very large sort of a precision that you can go to, right? You can say, after points, how many places do I want? Maybe I want 12 places, I want 15 places, I want 20 places. Where will you stop? So this is something you don't have to choose. The question itself chooses for you. If a question talks about decimal binary search, or the first way to understand that the question is decimal binary search is where the question will actually give you that line that please don't report an answer that is going above, let's say, 10 to the power of negative 4, for example. So that means they want you to find an answer which is up till 4 places, it's good enough. So now, if they do something like this, I'll make it a little shorter. Let's say they just say that you have to go 10 to the power negative 2, for example. So that means they are saying that you find something like 10.34, for example. So what does this mean now? What does this mean? This means that right now my limit was, or my integer was like 3, 4, 5, 6, 7, so on. But now this time, if I actually have, let's say, this as low and this as high, then I will not stop here because these are not integers anymore. I am talking decimals. So I will try to go 4 plus 5 by 2, which is 4.5. Is that correct? Right? Next time, this is just one precision place. So I will say that, okay, next time I will also try to do 4.5 plus upon 2, that is like 4.75. I will try to go that place. Correct? Now tell me, do you understand this, that initially when you said you are trying to go places, you used to do something like this: answer plus 1, answer minus 1. Why did you do plus 1 and minus 1? You did a plus 1 and minus 1 because you were on the integer. You were on the integer number line, right? So whenever you are at 2, you want to jump to 3. You don't want to go somewhere from 2 to between of 3. Correct? You want to jump from 2 to a 3, 3 to a 4, 10 back to 9, for example. So that was plus 1 minus 1. But this time, you are saying that, okay, if I am at 4 and I am at 5, for example, then I want to go to 4.5. Ideally, if you want to go to 4.5, then try to think this again. You want to come even down. Ideally, what you are trying to say is that if I am saying 2 decimal places, right? So 4.01, then 4.02, 4.03, 4.04, so on, right up till 5. This is actually the new search space between 4 and 5. Because अब ये आंसर्स भी पॉसिबल है, क्योंकि मुझे बोला है क्वेश्चन में कि मैं 10 पार नेगेटिव 2 तक जा सकता हूँ. So I know that 4.01 is also a possible answer, right? 4.02 is also a possible answer. So between this 4 and 5, you have exactly, I think, what? You can say 100 more values, right? Can you say this? 10 power negative 2 means 100 more values. Everybody agrees still here? So I have 4 से 5 के बीच में 100 values. Similarly, I'll have 3 से 4 के बीच में 100 values. Correct? Similarly, I have 1 से 2 के बीच में 100 values. Correct? So if I say that right now, what was your search space? Your search space, let's say for integer decimal, integer binary search, was just 100 numbers. Correct? अब हर 100 number के बीच में 100 numbers और आ गए. So can I say that the new range, the new search space has become 100 into 100? Or rather, the best way to write this would 1 upon 100, or rather 100 negative 2, right? So that is what you got multiplied. That is 10 power negative 2, sorry, correct. And then this becomes 100. So now you have 1, 0, 0, 0, 0. You have these many numbers to search from. Is this making sense? Integer binary search said you just have 100 numbers because you're doing plus 1, minus 1 and all that. But अब 4 आंसर के अलावा 4.01 भी possible है, 4.02 भी possible है. तो 4 और 5 के बीच में 100 आंसर्स possible हैं. Similarly, 5, 6 के बीच में 100 आंसर्स possible हैं. तो overall 100 आंसर्स को प्लस कर दिया, तो overall total 100 into that is total of 10,000 answers possible. So my search space has increased a lot. Is this making sense? This is now tell me, you know binary search that applies like this, right? You know binary search like this. What is the difference here and here? Just the search space. So what I can do is, if let's say I'm writing a while and I'm saying that okay, low less than equal to high, and then I say okay, some checker function, whatever that is, and I get something like true or false. So let's say this is the true block, this is the false block. Now initially you would have done low equals to mid plus 1. You would have done high equals to mid minus 1. Why? minus 1 plus 1 because you're integer division. You had integer value search. All I can do now is make this as P. P is how much precision I want. That's all. This is decimal binary search. So when people try to scare you off and say कि point के आगे तो निकाल ही नहीं पाओगे, वहाँ पे कुछ अलग algorithm लगाना पड़ेगा. It's not a separate algorithm. It's binary search, बस अब search phase बढ़ गई है. I'm searching more numbers. Does this make sense, guys? Okay. So as I said, I'm lazy. I will remember one thing and I'm going to apply it every. So I know this. I literally just changed P, which logically makes sense. I will be changing P because now I'm not jumping by 1. I'm jumping 0.01 all the time. Correct? Does this make sense? Okay. Cool. Any doubts still here? Okay. Now this is where थोड़ा सा problem आता है. Problem क्या है? With integers, you know that numbers are able to store integers. अच्छे से. They have that. So they have this idea of transistors and all that, registers and stuff. So they're able to turn on, turn off values. So they're able to understand that okay, you're trying to store a proper integer like 3, proper integer like 4 and all that. But with floating point, when you say that I'm trying to store 4.01, okay, 4.01, then uske aage se there are some zeros, right? Computer has a limitation, right? Computers have a limitation. They will say, okay, maybe I'll store up to 20 places. मेरा मूड होगा तो मैं 20 तक स्टोर कर लूंगा. उसके आगे I will forget. I don't care about. So the problem with this is that you have written a code that looks like low less than equal to high. When does this break? This breaks when high and low cross each other. Correct? If low goes above high and high comes here, तभी तो ऐसा होगा कि this will break. But now I will tell you what will happen with this algorithm if it is applied on decimal binary search. Now what will happen is you will have some precision. You will start doing that precision. You will say that okay, for example, you will let's say reach a phase where you have L equals to 3.00000001 and H high reaches 3.00000003 for example. Okay. Now you will do low plus high, correct? And you will do a variety. So you will get something like 3.00000000 and then I think a 1, 5, correct? This should be 2, for example, and then you're all. Okay, this makes sense? Aisa hoga? This will happen, correct? But the problem is, it's all dependent on the mood of the computer. The computer will come up to you and say, yeah, I don't have the power to store anything after this. Because बहुत सारा हो गया ना range मेरे लिए. ऐसे तो तुम करते रहोगे. You will keep on doing. You will go up to 20, 100 places. Where do you think you have to tell me I have to stop? You have to tell me somewhere I'll stop, right? So the computer will say, you will not know exactly. Computer अपना कर देगा, and वो क्या करेगा? He will say that हटाओ इसे, नहीं चाहिए, मैं स्टोर ही नहीं कर सकता इसको, because I had a limitation till here. Now I cannot store this. अब problem क्या है? You wrote a code that is saying low less than equal to high, correct? You wrote a code that says low less than equal to high. तो you must be expecting कि कभी ऐसा होगा कि low high को cross कर सकते, तभी तो you will break. You expect that somewhere low crosses high so that you are able to break. But now this is still low, right? This is still low. So there's going to be a point where low is never able to reach or cross high, because to do that, इतना decimal store कर ही नहीं पाया computer, so that you are able to cross high completely. Does this make sense? Okay, is this making sense? Yes. I cannot show this 5, so I might not be able to cross high anytime. And if I'm not able to cross anytime, how will I break out of this loop that I wrote here? Right? So that means this idea is the same as integral research, but this will change a little bit. Okay? Now this is why I started off with the story and said that, okay, you have to decide somewhere, right? Where will you stop? Now, it's either up to you, या तो तुम decide कर लो where you will stop, or the question will tell you where will you stop. So what will the question question say? The question will say that okay, please stop, or something like please. They won't write please exactly, but yeah, they will put something like this, and they'll say that please get the relative error. So they will say that please get the relative error. Okay, relative error till, for example, 10 negative 6. Now what does this mean exactly? This means that okay, let's not take 10 negative 6 for example. I have 7. Okay, I have 7 and then 8. Okay, so for example they'll say negative 8. So now what they mean to say is कि okay, you calculated your answer till here. Now इसके आगे you are going till 9 places, right? You have 8 places, you're going till 9 places. Don't go to 9 places. I'm happy with the answer which is within the boundary of this. Relative error means that your answer and the actual answer don't have a difference greater than this one, which is not possible because you have made sure that you are going till 8 places. तो तुम 8 places तक तो perfect answer निकाल दोगे. अब हो सकता है कि उनके आंसर और तुम्हारे आंसर में जो डिफरेंस बचे वो 9 places से start. For example, their actual answer is 3.0000000015. For example, this is their answer, but you report 3.00000001. So what's the difference? It will be 0.000008 zeros and then a 5. Correct? You understand the difference there? 0.00008 zeros and then a 5 is lesser than this. Make sense? Yes, guys? Okay? So that means now I know that if I have been given this sentence, then that indirectly means they have told me where to stop. So till when should I run? I should run till I feel y h minus l is greater than p. Till I know that the high and the low don't reach a difference which is going lesser than the precision that I wanted to maintain, I'm going to keep on running. And as soon as I know that it crosses that idea, that it says that okay, now you have reached a position where you are going to 9 places. Don't go to 9 places because अब इनका difference 9 places यानी 8 given 8 places से छोटा हो जाएगा. So you will automatically come outside this. Is this making sense? Any questions there? This side? Is this clear? I think. Okay. So so you have, for example, you have this L here, right? And you have this H here, for example. And you do a minus in this. So when you do a minus in this, what will you get? You'll get something like 0.000001, something, correct? Will you get this? This guy minus this guy, correct? Now, assuming that your p value is given as this, right? So what is this value exactly? I think this is this value, right? Correct? So now this is the difference, d, h minus l. Is h minus l greater than this p? It's not greater, right? It's equal to. Could be less also, but it's not greater. If it's not greater, then the question is saying please stop here. Because now if you stop here and whatever you report as your answer, I know that your answer has been calculated up till 8 places. And now because your answer has been calculated up till 8 places, I am happy with this answer. I don't want to go to 9 places. Do you understand now? Okay? So somewhere or the other, initially you must have started with something 3, some bigger number here, some bigger number here. And slowly, you must have reached 2 places. Then you start again by 2 Burla. You will have 3 places, you will again do by 2, 4 places, 5 places, 6 places, so on. Finally you reach 8 places. And as soon as you would have gone above that, this would have broken. Make sense? Okay, cool. Alright. I hope this part is clear. Great. Any doubts? Great. So So now we have established that integer binary search and decimal binary search has okay. No. No, I'm saying while it's greater, I would want to do something, right? As soon as it goes lesser, then I would break. Correct? Let me make sure. I think I'm correct, right? Yeah, I'm correct. Makes sense? See, I'm trying to do the binary search. I'm trying to do the binary search till I don't reach a position where अब I have calculated till 8 places. जब मैंने 8 places calculate कर लिया और अब मैं 9th करने जा रहा हूँ तब मुझे रुकना है। तो जब तक मैंने 8 places calculate नहीं किया तब तक इनका difference 10 power -8 से बड़ा रहेगा. Correct? Say let's say this number is let's say you had 1 and 100, right? So let's say this is 100, this is 1. 100 minus 1 is 99. 99 is greater than 10 raised to -8, right? So you will do binary search. फिर you will again say कि by 2 कर दिया तो it will be let's say 50 हो गया, ये 1 हो गया. 50 minus 1 is 49. 49 is still greater than 10 raised to -8. You will still do binary search. फिर एक पोजीशन आएगा जब h और l अब डिवाइड होना स्टार्ट हो जाएगा ऐसे कि अब डेसिमल्स आने लग जाएंगे. अब आएगा point, 1 place आएगा, 2 place आएगा, 3 place आएगा. It will eventually reach 8 places. And then you will say, okay, अब 8 places तक आ गया हूँ मैं. अब मैं रुक जाता हूँ. अब मुझे स्कैन करने की जरूरत नहीं. Clear? Okay. So we have understood that there is a very basic difference now that we are going to do while L less than equal to H and a while H minus L greater than P. And then inside, it's literally answer equals to, or low equals to mid plus 1, or we do a high equals to mid minus 1. But here we do low equals to mid plus P, and we do high equals to mid minus 1. Cool? Is this making sense? Right? This will solve binary search. Abhi tak I can stop here and give you problems and you can discuss problems. But I do one more thing. As I said, I'm still lazy. मुझे ये भी याद नहीं रखना. Because there's a difference, right? I have to identify is it decimal or not and stuff like that. Correct? This is decimal. This is decimal. I'll apply this. What if I do this confusion and मैं इसको less than equal to P कर दूँ? फिर तो दिक्कत हो गया, right? And यहाँ पे I have to remember it looks like this, right? Then I have to remember. I mean, this is good, even fine because this is just 1 and P. So you will just figure out that what is the possible answers. Right now, there the answers were 1, 2, 3, 4, 5. So you would have plus 1, minus 1. Now the answers, let's say, are 0.01, 0.02, 0.03. So you're doing a P. It's fine. P, if you place P equals to 1, then it's integer. Decimal binary search, right? Okay, integer binary search. Sorry. But I don't want to remember this. Okay, so a neat trick here. Let's start again with binary, simple binary search. So let's say this is 1 and let's say this is 100. And you do a simple binary search. Now tell me, when you do a simple binary search, you write a while loop, right? Now while loop doesn't look like a for loop. For loop mein pata rehta hai. Okay, we start with this and then we end here and while. Okay. Now have you done like questions like this when you were starting CS that convert a while loop to a for loop? Can you convert a while loop to a for loop? To do that you have to figure out while loop kitni baar run hai, right? Agar wo figure out kar liya to for loop chala sakta hai. Correct? If I ask you how many times can you run this loop? How many times would you have run a while loop if you were searching integer binary 1, 2, 3, 4, 5, 6? While you search की complexity होती है? What do you think is the time complexity? Log x, right? Log base 2x. Why is it log base 2x? Because you know that many times it will run. You will half 100 to each way, you will half 50, then 25 for example, then 12 and so on. So you can say that जो भी search base है, for example 100 है, I'll say log base 2 of 100 is roughly the number of times the while loop is running. Loop is running, correct? Okay. Now why 100? Because 100 search space, there were 100 numbers. अब we discussed decimal binary search. We said over there that now you have the number line. You have a number line. This is 1, this is 100. But this time, you also have 1.01, 1.02, so on. And then you have something like 99, 1.99, and then you have 100, for example. So now how many numbers do you have? 10,000. If I ask you the same question, हमने उधर भी तो while loop लगाया ना precision का, तो वो while loop कितनी बार run करेगा? You will say the same answer. Log base 2 on this. Make sense? Okay. So now what I can do is, if I know that how many times the while loop is running, roughly, if I know roughly how many times the while loop is running, then in my original solution where I was doing a while here and a while here, but I was doing both of them in a different manner. यहाँ पे it was L less than equal to H, यहाँ पे it was H minus L greater than B, and inside were same. Now I can say, I don't want this. I can write a for I equals to 0. I runs the number of iterations, that is log of search space. कितनी search space है? Similarly, I can write here for I equals to 0. I less than. इस बार कितनी search space? Make sense? So now this is a trick of mine. Now what do I have to remember? Nothing. I just have to remember one argument. Write a for, figure out a search space, write answer plus 1 minus 1 if it's integer, or plus p minus p if it's a decimal. Does this make sense, guys? Okay? So this is what I wanted to give as a theory. Alright, now I think okay, we are 5 o'clock. So let's try to solve problems. Cool? So I think this is the first problem. By the way, on code courses, everybody knows code courses, right? Right? So on code courses, there is a basic creation section above EDU. I'll show you actually. This section, edu section. Okay? If you go inside this section, and there are 2 courses. The second course is what you will find the problems in. So I've also put this in the PPT. Alright, so you might open the problem later if this PPT comes up to you, and you might think that so you might open this PPT later and you might think that I gave you a problem but it will open me only. It will not open because you haven't registered in this course. Okay? So it will first open you to a link that looks like this. You can register it, simply saying enter. I have already registered, so when you will enter, you will say that okay, registered. And once you have, then I think you can open this problem. So, first of all, why is this binary search? We'll discuss this. Then why binary? Decimal binary search. We have said there are n ropes. Okay. By the way, I think you should have some time to read this first. Okay. So, I think it's on the screen. If you can give this a read yourself first, and then I'll start. Okay. We have one. m ropes, I need to cut k pieces of same length from them, find the maximum length of pieces. So for example, I have been given 4 ropes, okay, and I need to cut 11 pieces. So according to them, each piece can be maximum 200.5 length. If I am able to calculate this, I think 200.5 length k, I can get 11 pieces from these 4 ropes. Right? Of course, if 4 ropes separated, so you will have to figure out how many pieces are you able to get from 802. 802 में से, if I have to ask you that, so let's say right now they are saying that from 802, how many pieces can you get of the length 200.5? How will you do that? Divide, correct? 802 divided by 200.5. This will be 4 exactly, right? Is this right? 4, yeah. Okay. So you will be able to get 4 pieces from here. अगर कोई और rope है, if that other rope is something like x length here. So how do you figure out how many pieces can you get from there for 205 length? You will do a 200 divided 200.5. And this will be an integer division, right? Because you have a piece, you have a piece, you have a piece, and then thoda sa bach gaya. Correct? So thoda sa bach gaya, if you have to just get that, you can say that, okay, let me do a floor division. Correct? X upon 200.5 will give something 3, let's say 4 point something, जो भी देगा, something point जो देगा वो मैं हटा दूंगा, because वो तो एक छोटा सा piece होगा, full length होगी उसकी, so I'll remove that. So this should be an integer division. Up till here this part is clear? Yes. So let's see the question now. I have said that I have some ropes A1, A2, so on till N. I am trying to get K pieces, and I am trying to find a maximum length M. Okay. So assume this is not binary search. ये binary search नहीं है, वो topic था इसलिए समझ में आता है, hint हो गया अपने आप, it's okay. But this is the not binary search. Let's go to the first principle. I said you need a monotonic predicate state. Right? You need a monotonic predicate state. So first let's ask a question. Let's start with a question. Let's say that you choose a m length. M length तुमने पकड़ी और तुमने बोला I need to make the rope size as m. Okay? If you need to make the rope size as m, then how do you think that will get verified? That will get verified if you are able to make greater than equal to k pieces of that size. तभी तो m satisfied है. If you say that I choose m, some random m, some number, and मैंने बोला कि the rope size that I will make will be m. That means you need greater than equal to k pieces. Then only m is true. Yes, this m is good. Good to go. You can choose this m because you can get greater than equal to k pieces. But if you are not able to make k pieces, or you make less than k pieces, you can say this is a false. Is this making sense? Correct? So this is the predicate nature. That okay, I was able to boil my question down by choosing something. That thing that I did, the thing that I chose is my answer. Answer was saying कि m size बताओ क्या बन सकता है. तो मैंने m के ऊपर ही बाइनरी सर्च लगाने का ट्राई किया. मैंने बोला चलो ठीक है, m को ही मान लेते हैं. क्या पता मैंने m बना लिया. कैसे बना लिया? या तो ऐसे बना लिया या ऐसे बना लिया. ऐसे बनाया तो ओके ट्रू आया, ऐसे बनाया तो फॉल्स आया. तो प्रेडिकेट तो दिख गया. I can see there's a predicate nature. I have boiled down my whole problem to a true or false. But is there monotonic state? Still necessary. See, why am I saying this is because I don't know how many of you have heard of. There is something called as ternary search. Right? Binary search, ternary search. Ternary search में monotonic nature नहीं होता. Ternary search ऐसा दिखता है या ऐसा दिखता है, hyperbola बन जाता है. तो उस केस में ये चीज पूरी गलत हो जाती है. So we need to understand that only monotonic is not helping us. We need to understand is it predicate. Now let's see. How do we understand this is predicate? Now let's say that you said some m length is possible and you figured out this is a true. That yes, I was able to make greater than equal to k pieces, so this is a true. Now tell me, you made this length, for example, m, and you said greater than equal to k pieces possible. अब मैं अपनी लेंथ को ऐसा कर दूँ. अभी पॉसिबल होगा? कैन आई मेक ग्रेटर देन इक्वल टू k पीसेस? इतनी लेंथ में तो पॉसिबल था. अब मैंने लेंथ और छोटी कर दी. फॉर एग्जांपल आई वाज एबल टू मेक ग्रेटर देन इक्वल टू k पीसेस विद द साइज ऑफ 4. अब मैंने बोला 4 का साइज का बदलो, अब ओनली 3 साइज का. सो नाउ फॉर 3 साइज आई कैन स्टिल मेक ग्रेटर देन इक्वल टू k पीसेस. जब 4 के बना लिए तो वो सारे पीसेस में से एक काट दूंगा और मुझे 3 लेंथ के मिल जाएंगे. Right? From all these 4 pieces that I made, I can just chop off one extra and I'll get 3 pieces, 3 lengthed pieces. So if this is possible, if this m is possible, then so will be m minus 1. Yes, so will be m minus 2. So will be m minus 3. Right up to, let's say whatever that lowest size is, let's say 1. Okay? Or rather in this case, we'll come back to the problem and see. But यहाँ पे they have said that okay, some low. Okay, for example, let me इसको low ले. एंड लेट्स से मैं ये m नहीं बना पाया. इफ मैं m नहीं बना पाया इसका मतलब है आई वाज नॉट एबल टू क्रिएट ग्रेटर देन इक्वल टू k पीसेस फॉर अ लेंथ m. सो इफ आई मेक माय हैंड इवन बिगर कैन आई डू दैट? जब मैं इतने का ही बना पा रहा हूं तो मैं इतने का कैसे बनाऊं? राइट? सो आई कैन से दैट ओके इफ दैट वाज नॉट पॉसिबल m plus 1 will also not be possible, m plus 2 will also not be possible, so on to whatever that high is, it will not be possible. Make sense? So now I can say that I know there is a false, there is a true. And I know there is trues and then falses. So there is predicate and there is monotone. Something like this. Sorry, something like this. Right? Something like this. ऐसा टाइप का? No. Like this type. ऐसा टाइप का होता है, right? Trues and then false. Right? So I have a predicate, I have a monotonic state. Means I can binary search. And what do I have to binary search on? मेरे से बोला maximum m find करो. That means I'm trying to find this, you know, that just one m जिसके आगे सब खत्म हो गया. That last m or that last true where I was able to make greater than equal to k pieces because उसके आगे I'm not able to do that. Is this clear, guys? Okay, so this is where this is a binary searching problem, right? Now, if you did not know the topic, how do you start off with? How did I start off with? जो आंसर जिस चीज को निकालने जा रहे हो, राइट? आंसर में कुछ तो दिया हुआ ना, फाइंड m, फाइंड k, मैक्सिमाइज दिस, मैक्सिमाइज दैट. वो जो दिस है ना, उस दिस पार्ट पे लगाना है. दिस इज बाय एक्सपीरियंस एंड ट्रेनिंग. यू सी अ प्रॉब्लम एंड यू फाइंड दैट दिस फाइंड करो. तो पहले दिस को पूछेंगे कि दिस पे बाइनरी सर्च लग सकता है. कैन आई फाइंड अ बाइनरी सर्च ऑन दिस? व्हेन आई स्टार्ट दैट, माय नेक्स्ट स्टेप इज टू फाइंड कि ओके इस पे बाइनरी सर्च लगाया और लेट्स से ये आंसर आ गया, तो कैसे आएगा? ट्रू से आएगा, फॉल्स आएगा? पहले प्रेडिकेट बनाया उसके ऊपर. सो आई सेड ओके आई वांटेड टू फाइंड m. सो लेट्स से मैंने चूज कर लिया, मेरे हिसाब से ये m बनने का कोशिश कर रहा हूं मैं. आई एम ट्राइंग टू मेक दिस m. आई एम ट्राइंग टू मेक दिस m. हाउ कैन आई मेक इट? आई कैन मेक इट व्हेन k इज ग्रेटर देन इक्वल टू k, or the pieces that I get of this m sizes I am able to cross, you know, k. And if I am not able to cross that, then it's a false. So now I have a predicate measure that okay, I was able to boil the problem down and say it's true or false. If I have picked up an m and I'm able to make greater than equal to k pieces, it's a true. M is possible, else it's not possible. Clear? Okay? And then I said a monotonic state. अब ये monotonic state किसी भी तरह की हो सकती थी. I have picked a problem right now which looks like trues and then falses. It could also have been the problem is false, 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 then trues. Right? Depends. Maybe like right now in this problem they are saying find this last true. Maybe they can twist the problem and they can say minimize something. When they are saying minimize something, they might mean that they are trying to find the first false, for example. So the problem can change here and there. They might ask maximum, minimum, minimize the maximum, maximize the minimum. But eventually they are trying to find this guys. So you have to figure out क्या ढूंढने का try होगा. So I am trying to find this guy. Okay? Cool. Alright. Now forget that there is any decimal binary searching on this. How would the whole idea look like? I'll say that there's a while loop, there's a low less than equal to high, okay, and then I'll say that okay, let's say there's some checker function, I have some mid, the mid is low plus high by 2. So I'm trying to ask, ये mid मेरा m, this is my m. So I'm trying to ask, can I make mid? Can I make mid means, can I create greater than equal to k pieces with a mid size? जो मैंने select check this, what will the checker function look like? अपने आप तो बन नहीं जाएगा, I will have to make it, right? How will the checker function look like? Checker function has this mid, right? Checker function has a mid. So the checker function says that, okay, you gave me an m, and you are trying to ask how many pieces can you make. Those pieces should be greater than or equal to k. So पहले गिन लेते हैं. Let's say a count is 0, and I can say that, okay, this count 0 will increase. I'm trying to count the number of pieces I can make. How can I do that? I'll go in the array of ropes, right? Let's say this is r of I, some rope length currently I have. I will divide it by mid. This is going to be a flow division, and c plus equal to this. So मुझे r of I, that is individually एक rope length जो दिया है, उसमें से mid size के कितने pieces निकाल सकता हूँ? मिल जाएगा. I will get this for r of I. So basically I will get this for r of 0, then r of 1, then r of 2, r of 3. So जो भी 4, 5, 10, 20 जितनी भी ropes दी हुई हैं, all the ropes I will figure out that what can I get the count overall number of pieces. Of course they are of mid size, right? Is this clear? Okay. And then the c guy is supposed to be greater than equal to k. Correct? The c guy has to be supposed to be greater than equal to k. Then you will return a true. If it's not, you will return a false. Any problem there? Folks, any problem? There? Any problem? Getting this? Cool? Okay. So I have the checker function. I said, okay, I am able to figure out the number of pieces, and then I am able to tell you that will mid work or not. Now, if you say that mid worked, then where am I? I am somewhere here. तभी तो mid work. If I am here, then I means I am somewhere in the true parts. If I am somewhere in the true parts, then I am happy. I want to note the answer, but I can do better. So I will say, okay, please note the answer. Say answer equals to mid, and this time make low equals to mid plus 1. Move forward. I am happy, but I want even better. So I will try to say you're somewhere here, maybe. Remove all this section and move even better. So move to this part. Make sense? Else, you would have said, okay, this means that, alright, I don't need to note an answer. Why? Because I am in the false area. So because I am in the false area, I can say that I don't need an answer. I don't need an answer, that means clearly, I will not note it. Correct? So I'll say I will not note an answer, I'm not happy, and I'll try to do something on the left side. Because if I'm here, then वहाँ तो answer है ही नहीं. There's no answer here. So I'll bring my high backward. I'll say, please, whatever this high guy is, jump here. You're not at a location which is feasible. You're at a place where I'm not happy. Please make the high go this side. So I'll say, high is mid. Alright? This is the problem solved. Problem is solved. Okay? Now this is integer binary search. But the problem said, if you read this, they said that, okay, oh, I've been logged out. Interesting. want to work in decimal, right? You want to work in decimal state. So because the problem said that, then let's look at the constraints once. थोड़ा सा slow है. So I think I can see that there is an input given where nk, okay, but what is the length over here? Length is 10 per 7, right? So for an integer binary search, it's 10 per 7, right? For an integer binary search, it's 10 per 7. Can you say? Because what can happen is, let's say you're trying to create one size pieces, right? So you can create a lot of pieces, right? For example. So do you agree with this, that the integer search right now is still 10 per 7 order? Correct? Any problems there? No problems? Okay. But now they have said this line. This is the line that you don't get to write yourself, and I don't think they have written a please also. So yeah, they have directly said that you have to output one real number. Maximum length of pieces that you can get, of course, we are trying to find. Answer will be considered correct if the relative or absolute error does not exceed 10 per 96. So what does this mean? They have said that 10 per 7 to normal integer order था, but now your answers can also look like 1.00000001, like up to like 6 places. It can also look like that. Okay? Because it can look like that, so now your search space has increased. Is that correct? Your search space has increased, right? Your search space has increased and it has gone to, let's say, 10 per 7 was initially. And then in every 10 per 7, you can assume that you have 10 per 6 more numbers. Right? So you can say, कितना हो गया? 10 per 30. Correct? Okay? Now, because it's 10 per 30, so remember, how did the idea work where precision is failing? You go up till 9 places and then you figure out, oh, 9 to story नहीं हो पा रहा, वापस आ जाओ. So if you have to go till 13 places, then let's take a search space till 10 per 14. एक थोड़ा ज़्यादा ले लेते हैं, ताकि अगर हम जहाँ आंसर हमारा फाइनली खत्म होगा, हम 13 तक तो perfect आंसर निकाल लेंगे. Does this make sense? Right? Okay? We showed that diagram, right? We said 8 places तक है. 9 पे we will stop. How do we know we have to stop at 9? Is because we will say 9 तक गए, फिर stop होके वापस आ गए और हमने 8 तक आंसर कोड कर दिया. We know 8 तक हम perfect error में. So now if the question is saying that there are total 10 per 13 search spaces, then I'll say okay, let's go to 10 per 14 for example, and we know 10 per 30 तक तो आंसर तब तक बढ़िया निकल ही आया. उसके बाद when I report it, तो मेरी relative error will be what is needed. It will be below the limit. So automatically I will get a fast solution. Clear? So now we don't need to do any while looping. What we'll do? Let's look at the code. So you take n and k. You take the vector input, right? This part is clear. And everybody codes in C++, right? They're able to understand basic C++, right? This is n, this is k. You take the input. This is the vector. You take the vector. Clear? This is the rows. Array of I is rows. Okay? Sorted? Now what is the error? If I can go, okay, 10 per negative 6 दी थी, तो मैं एक और ले लेता हूँ, ताकि I can go to 10 per 14, right? So I can take 1e negative 7. Clear? Then left is 0, right is 1e7. That's the maximum stuff that I can make. Either I can make no row, for example, 0 rows, or I can make maximum these rows. Okay? Sorry, maximum this length of rows. Either I make 0 length of rows, that means nothing, or 1e7. So now what is the search space? 10 per negative 10 per 14. If you do a quick log check on this, it will come roughly as, I think, little less than 50 iterations. So now I don't need to run any for loop, any while loop. What have I done over here? I have a for loop. It runs from 0 to 50. In this while loop, I have this mid. Of course, this mid is going to be the double type because you want double numbers, right? Integer कर दोगे तो integer loss हो जाएगा. So you can say left plus right by 2. Double mid aa gaya. You place it in the checker function. You say, oh, you think that it's true. Make the answer as mid, and left is mid plus error. Mid plus error because error is that t, right? Because this is decimal binary search. So we would have done mid plus 1, but now it's decimal, so it's mid plus error, mid plus p. Else, do a write of mid minus. And then I can just print this answer. Of course, I need till 7 places, so I can take help of set precision as the function. I'll place with 7 answers, 7 places, and I am done with the answer. And the helper function looks like this. I am counting the pieces. Okay, I'm saying pieces, ropes, divide. If it's greater, if it's already greater, then great, return a true. If it never became greater, then outside the second return a false, because I know I haven't made enough pieces. I needed total ropes or k or whatever. I was not able to do that. No, please return a false outside. If you were able to do it somewhere middle me, please return a true. Okay, so this is the code for this problem. And again, as I said, this is going to work everywhere. Now, had this been an integer problem, you would have said same code करते हैं, बस यहाँ पे 30 के बजाय let's say we 50 बजाय we run a total 30. Because now you would have said it is still 1, 10, 7 only. ये error नहीं आती. Right? So the search space would have been just 10 power 7 numbers. So whatever is log base 2 of 10 power 7, I think it's going to be 25 or something. So you can 20, 25 something. So you can take like up till 30 iterations and go back up. Now your search space increased in notified iteration. Is this clear? So this is the competitive programming sort of a way to learn binary search actually. Right? In actual DSA or in interviews, even if you tell the while idea, because I've given both, right? If you don't do the for idea, because you don't want one idea for everything and you want to explain it a little differently, you can of course tell the interviewer that, sir, I understand this idea also, where if it was integer, I'll be doing this. If it was a decimal, I'll be doing this. Because precision is lost. So I know ye by alag chal jayega, but I have also understood that effectively this is just while loops. If I'm able to figure out kitni bari while loop chal raha hai, so I can just replace both of them with a for and I'm done. Does this make sense? Okay? Good enough? एक और problem करें? Alright? Great. By the way, I think my screen is sharing. By the way, yeah, what is the time complexity of this? I mean, I shouldn't do that anyways, but I think you understand the time complexity. Search space 50 times into your checker function set. I'm running int, right? Whatever that size of the array is. So, हर 50 times you are running int. So that's like 15 to n. और 50 आया कहाँ से था? That was log based. That is why binary search is called as n log n, right? Overall, when we write binary search, we call it n log n. N comes from that checker function, and log n comes from the actual binary search, where you halve your values. Clear? This should not be a confusion, by the way. Don't remember binary search complexity n log n. Sometimes I hear people say that binary search complexity is n log n. Binary search complexity is log n. This extra n is coming from the complexity of how much time did you take to check whether it was true or false. It could also be above n. That's a different thing that you might have solved problems till now where this is always n, so you remember it's n log n. But for example, let's say यहाँ पे I'm doing some other logic. Let's say मैं कुछ n square में कर रहा था, तो I would have said n square log n. Correct? Make sense? Okay. So this part is clear. So this is this again. I think I have misspelled this. This is problem 2. Any doubts still here, by the way? Right. I try to make binary search easy because decimal value keys become the. Yeah. Till then, any doubts? Log in quickly. when you go in the HU section, this is how it will look like. So you have other topics like suffix array, segment trees. So when you go in the HU section, it is going to look something like this. Okay, you will have problems with suffix array, segment trees, binary search, DSU, two-pointer. So you can practice from here also, if you like. Right? My problem should be here. So this is one of those problems जहाँ पे तो binary search एकदम समझ नहीं आएगा कि क्यों लग रहा है और कैसे लगेगा. So this is a little advanced problem. That's why I'm asking again. Everything is clear till here, right? You understand the for idea, while idea, and everything. Okay. So. Just try to understand this. Can you read this once? Right. So given n pairs of positive integers, so this is a pair like a1 comma b1, a2 comma b2, a3 comma b3, and so on. Right? What do I have to do? I have to select some k numbers, for example. Select k of them. Okay? Select k of them. I1, I2, so on, Ik, so that the ratio is maximum possible, and this is how the ratio is. Alright, everything is given in roughly 10 to the power 5 order. Okay. N is also given, K is also given 10 to the power 5 order, and absolute error 10 to the power negative 6. Okay, good. So I think my screen will go away. So let me go to the actually, and just go mark it so that we don't come back here and waste time. So what is the problem saying? The problem is saying I'll give you something else. A1, B1, A2, A2, A3, so on as their A and B. And then I'll say I'm going to give you a K. Big fat C. Okay. I'll say that pick up any K pairs from this. Pairs. When let's say I pick A1 to B1 अपने आप आता है. I have to pick K pairs from this. So let's say K was given as 4, and let's say I pick up some 4 pairs. A2, A3, let's say somewhere A and A1, something. So I pick up, let's say 4 pairs. Now when I pick up these 4 pairs, there's a formula that will automatically get made. Let's say when I have 4 pairs, let's say when I A1, A2, sorry, A1, B1, A2, B2, A3, B3, A4, B4. So now the ratio will look like A1 plus A2 plus A3 plus A4 upon B1 plus B2 plus B3 plus B4. Now, mind you, I have picked up 4 values like this: A1, A2, So इसको ऐसे डिवाइड करूंगा तो कुछ रेशियो निकल के आएगा, right? Some value will come, some decimal value. Okay? I have to maximize that decimal value. So I picked up these 4 values. तो इससे कुछ value आई होगी. You might pick up some other 4 values. इससे कुछ और value आएगी. कोई अभी और खड़ा होगा बोलेगा मैं ये 4 values लाऊंगा, कुछ और value आएगी. तो saying that K4 है, K is given, you have to pick K values, but pick them in such a way that they create the maximum ratio. This should be maximum. This guy has to go maximum. Okay? I hope this is clear. Is the problem making sense? Yes? Now I'm going to tell you one very straight intuition which people will do. Do you think you will do something like this? I'm going to do A1 upon B1. I'll calculate A1 by B1. Okay? Let's say this is whatever. Let's say something like B1. Okay? Then similarly I'll calculate B2, B3, B4, so on till Bn. यानी मैं सबके ratios calculate. A1 by B1, A2 by B2, A3 by B2. I'll calculate all this. And जब मुझे इसको maximize करना है, तो I can pick up the top K values from this. And I can sum them. Do you think this is a solution? Yes. You do A1 by B1, you get some ratio. A2 by B2, you get some ratio. You get n ratios like this, and you pick up the largest K ratios, and you add them. You add those K ratios. Make sense? So this is one of the approach, but this is wrong. Why is this wrong? See, I don't like math myself a lot, so I understand why you guys might frown. What is this math? But again, very simple maths here is that if you take these ratios and you add them up, what are you doing exactly? You are doing something like this. A1 by B1 plus A2 by B2 plus so on. Are you doing this right? And what were you told to do? You were told to do A1 plus A2 plus A3 whole upon B1 plus B2 plus B3. Are these two things equal? No, they're not equal. Make sense? So when people see this problem, they say greedy. Interview problem देगा and you will say greedy. मैं ratios निकाल के top पे उठा दूँगा like that. That will not work. Correct? Because this is mathematically not equal to this. Is it? By the way, nobody has this doubt, right? This, if you do, like I think if you do this, for example, this will be like B1, B2, and then A1 into B2 हो जाएगा plus A2 into B1 हो जाएगा. All that fractional mathematics, right? I don't like that. So, of course, this is not this. Okay? Now, this is where we can think binary search. Now, why? See, first of all, again, ये binary search की problem है, मैंने बता दिया तो you will start thinking. But let's go to first principles. Last problem में what we did? We said, there is something I want to find. Let's put it under the scope of binary search. So what do I want to find? I want to find a ratio. I want to maximize that ratio. Okay? So अब उसी से start करते हैं. Let's say I'm trying to binary search on the ratio. Binary search on ratio. तो let's say मैं प्यारा सा ratio बनाता हूँ x. मैं check करना चाह रहा हूँ, can I make a ratio x? Okay? Now if I have to make a ratio x, or let's say everything is going well and you have made a ratio x. If you have made a ratio x, then क्या हुआ होगा? If you have made a ratio x, तो क्या हुआ होगा? ये हुआ होगा कि तुमने कुछ k values उठाई होंगी, और उन k values या उन k pairs को जब तुमने इस फॉर्मूला में डाला होगा, तो तुम्हें जो रेशियो आया होगा निकल के वो x हो गया होगा. करेक्ट? तभी तो x बना होगा. Does this make sense? Yes? Right? If you say that x is possible, if you say that x मैं बना सकता हूँ, that means you must have picked up some k pairs, and from those k pairs you must have achieved this ratio. Okay? So let's say that you picked up some random k values. You picked up some random k values. Let's say you picked up a1, a2, so on, something like a upon b1, b2, so on till bk. And this became equal to x. Now, there's a small problem here. You're figuring out ratio, right? Tell me, this side, right? This side. This is also a decimal. This is also a decimal, right? Decimals cannot be equal to decimals because precision इतना ज़्यादा होता है. ये वाला जो side है, इसमें हो सकता है 20 places तक precision है. This side might end in 5 places only. How do you compare, right? So it cannot be equal exactly, but rather it's better to say कि if I know x is possible, then maybe I have made a ratio x, or I have made it greater than equal to x. दोनों cases में I'm happy, right? If If I made a ratio greater than x, तो और अच्छी बात है. मैं तो x निकालना चाह रहा था, मैं तो x ऊपर निकाल दिया. Wow. x निकालना चाह रहा था, x ही निकल आया. Amazing. x से नीचे निकाल दिया, तो मैं बोल सकता हूँ कि यार I'm not happy. I wanted to make x, I'm not happy. Is this making sense? Yes. I wanted to make x, I made a ratio greater than equal to x. So now let's check if this is possible. How do I check this is possible? This is first of all a really bad equation. Now this is again a hint here that in C++ or in DSA or in CP, anywhere problems, any problem that looks like decimal is a problem which you should not do in decimal. You should do it in integer. Can you make this problem look like integers? You can. What is the culprit here in each other portion? In each other portion now, then I don't have a denominator. I'm not talking in decimals anymore, right? So let's remove this guy. How do we remove this guy? What is the equation? The equation is I have a1, a1, a2, a3, so on. I selected some a pair, so let's say a. Okay? I have b1, b2, b3, so on till bk is greater than equal to x. Can I move this guy here? Can you move this guy here? Yes. So what will it look like? It will look like a1 plus a2 plus a3 dot 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 ak is greater than equal to x into b1 plus b2 plus b3 so on till bk. Right? What if I bring this guy this side? If I bring this guy this side, what will happen is it will look like a1 plus dot 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 till k minus x into b1 plus 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 dot till b is greater than equal to 0. Yes? Is this correct? Okay? Up till here everything is making sense? Yes? Basic maths. Denominator ले गए, इधर गया. Cool? Now, if I look at this number, a1 and xb1. What is x into f, right? So that will be xb1, xb2, xb3, xb4, right? And corresponding to every xb1, xb2, xb3, so on till xbk, I have a a1, a2, a3, a4 till ak. So can I say that this is looking like this? a1 minus s xb1 plus I can say a2 minus xb2 plus so on ak minus xbk is greater than. Yes? Does make sense? Now this is where I can figure out the binary search. Because listen to this. You start off by saying that can you make a ratio x? Right? Now I am saying you can make a ratio x और कैसे बनाओगे उसको? एक काम करो, तुम पूरी array अब देखो, I wanted to pick up k values, right? मैंने बोला if I have to make x ratio, then you have picked up some k values जिससे you were able to make it. कौन सी k उठाएं? कैसे पता? We don't know, right? Which k we have to pick up? How do we select those k values? Do we actually select those k values? I think it's not needed. Why? Because what you can do is the actual array looks like this. When you start off, the actual array looks like this: a1, a2 till an. N values of a and b1, b2, so on till bn. N values of b. You are asking for x, so I can make a third array. I call it a transformed array. Transformed array. इस array का हर number कैसा दिखेगा? अगर मैंने एक x pick कर लिया, if I have picked up an x, then every number in this array is going to look like this: a1 minus xb1, so on till an minus xbn. All the numbers I have transformed each number and I have converted it to look like this: ai minus bi, something like that, ai minus xbi, something like this. Okay. So now this is the array. And what is the question? The question is, can you pick up k values? Listen to this carefully. Can you pick up k values from this array which have a sum greater than equal to 0? ये तो बहुत easy है, right? अगर मैं तुम्हें क्वेश्चन अलग से दूं कि क्या तुम्हारी array में k नंबर्स हैं जिनका सम greater than equal to 0 है, तो तुम क्या करोगे? तुम सबसे लार्जेस्ट वैल्यूज ले लो, पिक अप द टॉप k वैल्यूज इन दैट एरे, एंड अगर उनका सम ग्रेटर देन इक्वल टू 0 है तो आई एम हैप्पी, और अगर उनका नहीं है तो किसी और का भी नहीं होगा. Does this make sense? Yes. If I can pick up the k values, top k values from here, and they have a sum greater than equal to 0, I'm happy. If those top k values don't even have the sum greater than equal to 0, then और किसी का तो हो ही नहीं. Correct? So that means I have figured out that I started off with a predicate question, or was finding a predicate question. Can I make this x or not? And I have derived that yes, I can make it if I transform the array like this and pick up the top k values from this. If the sum of these top k values cross 0 greater than equal to 0, then I'm happy, else I'm not happy. If I'm happy, then x is possible. If x is possible, then I'll try to make more x. I'll try to jump even ahead and say, I'm happy, let's note this answer, let's jump even ahead. If I'm not happy, then I'll say, don't note the answer and come back. Clear? Alright, so now what will the code look like? I'll say, okay, I have this vector of pair of double double because I have two values, so right, a1, a1, b1, a2, b2. Then I take a first and second, correct? First means ai value, second means the bi value. Input ले लिया. Now in the problem they have said error till 10 power negative 6, तो मैं again same काम करूँगा, थोड़ा सा extra ले लूँगा, 10 power negative 7. Right? I'll start left with, I can start with 0 also, I can start with error also, because 0 ratio थोड़ा सा मुश्किल है बनाना. Why? Why is that? Anybody? Why is 0 ratio possible, or sorry, rather not possible? Because if you like select some numbers, they will have a ratio that is, I mean it cannot be 0 ratio, right? All the values are positive. I mean when you go back to the question, you will read that a1, a2, all these values are given greater than equal to 1. So how can you make a 0 ratio? 0 ratio to 1 is correct? 0 value to 1 is ratio. So I can start with error. I can say the lowest ratio I can make is 0.00001. This is the lowest ratio. Highest I can make is 1e6. When can I make the highest ratio? When all the a values are really large. So like let's say everything is very large and उनके corresponding all the b values are really small. तो सबसे highest ratio है, सबसे highest ratio 1e6 तक जा सकता है because range होता है भी. Clear? Any problem in this? Okay. And then, what is the search space? I mean, this is 10 power 13, and then you can take it roughly, whatever that is, like 50 iterations, 60 iterations, apni marzi ka, something which is greater. So on a larger limit, you can take like, I have taken 60 iterations, you can take like 50, 60 iterations, because whatever is the search space, okay? And then I'll say, okay, mid, left plus right by 2. Let's make the transform array. I have a mid ratio. I'm trying to create the mid ratio. So the transform array will look like first minus mid second. Okay, ai minus x into bi. So this is the transform array. Then I have the checker function. Right? Now in the checker function, I have written something like this. I've said, okay, let's do the checker function. So I'll come to the checker function. I'll say that what is the checker function? I have a double sum. Now I have to pick up the top k values in the transform array. तो उसको निकालने के लिए what can I do? Sort कर लेते हैं. If I have sorted the array, then the last k values will be the top k values. अगर reverse sort करो तो first k values will be the top values. Doesn't matter. So I have sorted the array, transformed array, and I have picked up the top k values. How I have done that? 0 to k loop, and this is n minus I minus 1. So this is features. Like how palindrome works, right? You write I and then write n minus I minus 1. So, features I am taking k values. And then is my sum greater than equal to 0? If it is, then great. Let's come back. Now, I have written over here answer equals to mid, and then left can be written as mid plus error also, and right can be written as mid minus error also. It can be written directly as mid also. Why? I'm not going to tell because it doesn't make sense. I have taught one thing, you can remember that. ये ऐसे नहीं चलता है. If you do plus error, if you do minus error, it doesn't matter. Okay, great. And now the problem is solved. Good. So, what is the time? Now, what is the time complexity? Fun part. This is what I gave in the last problem. ये तो भले 60 में चल रहा है, but ये नहीं चल रहा है. You are sorting it, right? So this is you're doing log n again. So you're doing something like n log n square, which is also fine. It's still going to run because n log n is also well below 10 power 8 to run and not run into TLE, and n log n square is also well below 10 power 8 to not run into TLE. So now you also know that binary search problems can look like this also. They are not always n log n, right? All depends on the checker function. अब ये of course यहाँ पे बात आती है कि मैं checker function अगर n square का बना देता तो I would have gone into TLE. So that also hints me that binary search तो चल जाता है log n, लेकिन checker function की एक range होती है. n log n बना दूंगा, n square शायद नहीं बनाऊंगा. Okay, so thinking of the checker function also is a thing that you have to do itself. अपने आप तो बन नहीं जाता checker function. You have to think the checker function, right? So you understand that, okay, I can make a checker function like this also. Interesting, right? So I think this is everything, and you guys stop I think. Okay, so any doubts? Right? Let's do a quick takeaway from the whole lecture. एक बार 2 मिनट फट से. Okay? Let's go back and see what did we do. So we started off with Captain America. Okay? This is the normal binary search. Everybody knows. There's an array, आधा फाड़ के खत्म. ठीक है? But this is not binary search. Binary search doesn't work always on an array. It works on a search space. There are some numbers in which you try to half yourself. Okay? So now, when you have to figure out binary search, it works on 2 principles. It should be monotonic, or as I like to call it, boring. Boring means it has only one nature. Decreasing, increasing, something. Doesn't do anything beyond that. And it's predicate. Predicate means, is the question always a true or false? The question that you ask, is it true or false? So if binary search has to work, this is how, by the way, decreasing and increasing has to work, right? If binary search has to work, the question itself should have a monotonic predicate nature. That the question is in a true-false manner, and when you answer that true and false, right, across all the values in the search space, it creates a decreasing or an increasing function. All trues, then some false, all false, then something. If it does that, then it's binary search. Okay, so we took an example, find x square closest from the left of 105. We understood that yes, I can see that there is trues and then some falses. So this is a predicate as well as a monotonic state. I need to find this guy. So I would have written a simple integer binary search everybody knows of. It would look something like this: low it will look something like this, right? That okay, low is less than equal to high, and you have a checker, right? And then this part is done. But now we expanded. We said जो Captain America कर रहा है, that is not true. It's a search space. So we said search space can look something like, let's say, 100 numbers. You're trying to search in 100 numbers. But now in decimal binary search, it's just not 100 numbers now. It's just more set of numbers that you're searching in. So okay, now my search space has increased, but will my binary search logic change? It should not. So we said that okay, if it doesn't change, then I am now searching, let's say, 10,000 numbers. So now my logic should still look like this. Just this time I am going plus p or minus p. When it was integer, I was going plus 1 minus 1. Now I will go plus p minus p because I am jumping 0.00 something, whatever that precision is. I'm not jumping plus 1 and minus 1. Okay? But we understood that if I do this, this guy is a problem. Because in computers have this issue with up till which place they can store. It's a problem. So to figure out that how do I handle this problem, the question only tells yourself, question आपको बता देता है that इधर तक जाओ फिर रुक जाओ, इसके आगे रहो. So we said okay, because of this issue that this, let's say 5 will be lost, for example, question tells me that go till 8 places only. So I'll go till 9 places and then I'll stop and I have 8 places answer done. So now my ideally binary search will have the same logic. It will have h minus l greater than p. Till I am not well below the relative error of decision, I will keep on doing my binary search. As soon as I am below that or equal to that, whatever, I'll stop. Because then my relative error is well within the boundary. Okay? So this is how ideally the lecture will stop now. This is where we would have, I said, we can stop here. If you remember this also, it's fine. You apply this for integers, you apply this for decimal. But 2 while loops, different while structure. I want a single line. So I said, effectively while is all about figuring out how many times is while running. अगर ये 100 बार रन कर रहा है, मैंने 100 बार एक for loop चला दिया, बात बराबर. अगर ये 200 बार रन कर रहा है, मैंने 200 बार एक loop चला दिया, बात बराबर. So I figured out that okay, a normal binary search in a procedure is, let's say there are 100 numbers, then it's log base 2 of 100. If there are 10,000 numbers, it's log base 2 of 10,000. So all I need to figure out is how many times it's running. That's log base 2 of the search space. So now I can replace all of these guys with a single for loop, search space, search space. दोनों में काम करें. Inside the loop still like +1 -1 +3 -1. Okay. So this is when we discuss problems. I think you remember the problems. Okay. Alright. So thank you everyone. I think any doubts? All good. Okay. Great. So let's stop here. Yeah. It's not related to this lecture. I mean, I can answer it. I don't have a problem. But okay, I can answer it. Yeah.
So my name is Dipali from Viraj.
Hi, Dipali.
I was working at a full stack with Burla in Bhubaneswar.
Okay.
So sir, I was wanted to tell that VSSUT has immense talent of students. So why don't companies like Google hire from this campus, or how can we apply off campus?
Right. So okay. So मैं इसको ऐसे बताता हूँ. I am from NIT. Google doesn't have from NIT. Right. So honestly, even today, the brand is not a problem. The problem is alumni base, or rather, alumni base who is willing to do something back for that company to take to the college. Sometimes alumni also tries to do. For example, now I'm in Google. I tried to bring Google back to my college, but there were some issues. Maybe the company wants to only explore up to certain level of colleges, which they deem are correct. And beyond that, they have off-campus plan. So the first question, to answer the first question, there is nobody's mistake there. Maybe the alumni tried to do it, it did not work out. Maybe the alumni never tried to do it. But it cannot be blamed on the college or the person. It's just that it's the company's decision, right? At the end of the day, it's a company's decision. You can put it this way, right? Company अगर आ भी जाती है, then you can ask why did the company pick from CS and not from civil engineering, for example. For example, let's say they do this, right? Then what will you say? You cannot say anything there, right? It's the company's decision. So at the end of the day, they are private MNCs, they might take their own decisions. So first question is sort of dependent on the company. The second thing is my story. I was an off-campus placement. How do you apply? There's a careers page. You pick up a careers page, you say, okay, I'm going to go there and you apply. But the problem is everyone of you will apply, right? So you will have a resume will have projects and everything. That's cool. You will have probably CP, you'll have TS and all that. But the question is, what do you have as an extra? This is a big story. How can I understand you're different than others? That's all. This X factor can be anything. Maybe this is that one project which has gone to production, has 1,000 users, and it's deployed also, for example, and anybody in your college does not have that. So then I know only you have it, correct? Make sense? This is an X factor. Or for example, somebody is doing CP and they are the only candidate master in the whole college. That's their X factor. Now, if you don't have an X factor, you will of course ask this question why I'm not sure, but I can guess that if you guys have applied to Google, as in your batch or any of the previous batches, किसी को तो call आया होगा. Some people must have gotten a call back of at least, just giving like, let's say 1 round, for example. Shortlisting हुई होगी, resume shortlisting हुई होगी. So when that happens, right, in off-campus sometimes, then this question pops up, that why was there this person who got selected for just giving, let's say 1 round, maybe uske baad they got rejected something, but it's fine. They got 1 round, right? I think I was told that you guys have some alumni in Google, right? So how did they reach Google, for example? They had their X factor. So when you say that I am preparing for this role, or any role, SD, data analyst, AI engineer, anything, you need to have that X factor. If that X factor is visible in the resume, then it's picked up next. It's either picked up by some algorithm which is shortlisting the resume, it's picked up by some HR, by some, you take some referral, right? You take some referral from somebody, HR reads the resume and they see that project. Okay, this project, oh, this guy's kind of master. Oh, have received 10 resumes, nobody's kind of master. Oh, I think I should give this guy a chance. Make sense? So this is short but discipline. If you don't have an X factor in the resume, it will be really hard to get into, at least I should say, companies which come in this water. Right? Yeah.
I have worked with the Himalaya Labs to develop Enigma, which helps me also declare.
I'm sorry, you have worked with Himalaya Labs.
Himalaya Labs.
Himalaya Labs, okay?
Okay. It's the startup, sir.
Okay, it's a startup. And?
We have developed a application named Enigma.
Okay. So are you allowed to reference that project in your resume?
Yes, sir.
Then good. You can reference that project. Do you think it is of that level which makes you X factor? Do you think it's a project which you see that nobody else has done so far?
Sir, in my class, I'm the only one who has some experience like this.
So that's a good point. Expand this. Go beyond your class. Tell your college. Do you think in VSSUT nobody has made a project like this?
No, sir, I'm currently pursuing my MTech first year.
Okay, got it. Do you have MTech friends in or many colleges? Let's say nearby, like in Bhubaneswar, is IT Bhubaneswar also, right?
Yes.
If you have friends there, you can search there also.
Yes.
The thing is, see, I'm trying to expand the search space here, right? In your college, it's good. In your class, it's really good. But ideally, it should be on at least a level where the colleges which are getting a call back, you should be competing there.
So, should I apply from second year or first year?
You can apply from day zero, whenever you are eligible.
Yes.
It doesn't matter. The company doesn't care when you apply. The company only cares when you apply, and if they want to shortlist you, they will look at everything nicely and all. If they don't like it, they will reject you. That's fine. That's okay. That's fine. See, understand this. If you take this journey right of applying and then getting rejected, then you will actually get into a company. You will look back and say, "कि मैं 20 जगह से reject हुई थी, और फिर मैं एक जगह I got in. Wow, what a story, right?" So it's fine if somebody gets in the first offer, somebody gets after 20 chances. It's all about everybody has to keep on applying, right? So it doesn't matter. Okay? Short put, it doesn't matter. You can apply.
Thank you.
Thank you. Yeah, how did I get the transform? Okay. So we said that let's say you pick up, let's say you're trying to make a ratio x. Okay? When you're trying to make a ratio x, कैसे बनाया होगा आपने ratio x? You would have made the ratio x by picking up some k elements which would have worked out.
Like how did you pick up the first k from the starting or anything?
No, I picked up any random k elements. Let's say I picked up some random k elements which worked for me. वो हो सकता है पहले से आखिरी से मुझे नहीं पता, but I have picked up some random k elements जिनको पिक करने से मैंने एक रेशियो ग्रेटर इक्वल टू x बना लिया. फॉर एग्जांपल, अब अगर बना लिया तो what should be true? We are checking this. I picked up some k elements. The ratio turned out to be greater than equal to x, which means that this should be this, this should be this, which means that this should have been written. So अब हम reverse engineer करेंगे कि okay, if I had picked up some k elements जो कि मुझे greater than equal to x ratio find कर लिए होते, बना दिए होते मेरे लिए, then that means I must have had some k values whose sum would have been greater than equal to 0. And those k values would have looked like this. Every k value would have looked like this. A1 minus a2. Make sense? Okay? So if x is satisfied, then there must be some k pairs in the array which you when pick, you will get this satisfied. Then only you can say x is possible.
Whatever the first x we did, how do you find that x?
That's the thing, right? We're not finding them. Achha, let's put it this way. The problem never asked you to print those k numbers. Problem में कभी बोला कि मुझे वो k pairs बताओ जो ये बना रहे हैं. Problem never told you that, right? So why do you need those k values? You never need those k values. You can all do imaginary. That whatever those k values are, they should satisfy this. इतना है. If they satisfy, then they can be the first k, last k, middle k, 1, alternate k. I don't know. Some k values will satisfy this condition. If they do, that means x is possible. Make sense? Clear? Okay.
Thank you, sir, for this exciting session. Thank you, attendees, for this session. I request again to please be present at sharp 8 a.m. tomorrow for our next session.